Hi, so you've learned how to do synthetic division. Now we're going to use synthetic division to evaluate polynomials. We've evaluated functions in the past where I'll give you an equation and I'll tell you to evaluate it at x equals 2. You plug in 2 for all of your x variables in the function and get an answer. This is actually a much easier way when you have long polynomials to evaluate polynomials. We're going to use synthetic division, or it's called synthetic substitution. We're going to use synthetic division to evaluate polynomials, called synthetic substitution. The process is exactly the same as synthetic division. The final answer is interpreted different, as described in the remainder theorem. This is a theorem we're learning right here. So, your remainder theorem. If the polynomial function, p of x, is divided by x minus a, then the remainder, r, is p of a. So we are evaluating a polynomial with a. So our answer is p of a. Let's do an example. Here's a polynomial divided by another. So we solve this for x, x equals 3. That's what goes right there. All of the coefficients, 1, -4, 5, and 1. Drop the 1 down and do your synthetic division. 3 times 1 is 3, add. 3 times -1 is -3, add. 3 times 2 is 6, add. That's your remainder. Therefore, P of A equals 7. We just evaluated P of 3. So evaluate the polynomial for 3, your remainder is 7, that's your answer. Example, use synthetic substitution to evaluate the polynomial for the given value. So here's your polynomial, evaluate it for x equals 2. Set up your synthetic division. We have all of our coefficients here, drop the 2 down. 2 times 2 is 4, add. 2 times 9 is 18, add. 2 times 17 is 34, add. That's your remainder. So your polynomial evaluated at 2 equals 41. Personally, I think this is a lot easier than substituting 2 in for each one of these values, crunching numbers, and hoping you didn't drop a negative somewhere. A little bit bigger, and a fraction. This is especially helpful when you are evaluating at fractions because when you start multiplying those fractions or raising them to higher powers, it can get sort of messy. Coefficients, we're missing a squared, so I need a placeholder. 6, -25, 0, -3, and 5. X equals -1/3. Drop your 6 down. Luckily, all of our multiplication works out with this. We don't get any fractions as answers. Multiply, -2, add. Multiply +9, add. Multiply -3, add. Multiply +2, add. Our remainder is 7. So your polynomial evaluated at -1/3 equals 7. Okay, let's try a few geometry problems. First I'm going to go over this. Area is length times width. Volume is length times width times height. So we can actually say volume, which is length times width times height, is actually area times height. And if we wanted to solve for area, you would divide both sides by h, area is volume divided by height. Very important for this next example. Write an expression that represents the area of a top face of a rectangular prism when the height is x plus 2 and the volume is x cubed minus x squared minus 6x. So we have area is volume divided by height. Volume divided by height. So if we take this, solve for x, we get x equals -2. It goes right there. Drop your first coefficient down, -2, add. +6, add. 0, add. Our beginning problem is cubed, so our answer is squared. I don't have any remainders, so our area can be written of a of x is x squared minus 3x. We came up with a expression that represents the area. One more geometry problem. Write an expression for the length of a rectangle with a width of y minus 9 and an area given. So if area equals length times width, we're looking for length. Length equals area over width. So we have area over width. Solve this for y, and it goes in the box. Coefficients, 1, negative 14, and 45. The 1 drops down, multiply and add. Multiply and add, we have a remainder of 0. Our beginning problem is a squared. Our answer is to the first power. So our length is y minus 5. And that's all we have for today.